Hello everyone. Today I am going to present my presentation on X-ray spectroscopy. Now, first I will introduce the X-ray. X-ray are first discovered in 1895. X-ray have much higher energy and much shorter wavelength. Most X-ray have a wavelength range from 10 picometer to 10 nanometer, and their corresponding energy range is 145 electron volt to 124 kilo electron volt. X-ray wavelengths are shorter than UV rays and typically longer than gamma rays. Here in electromagnetic spectrum, we see the X-ray are lie between gamma ray and ultraviolet ray. Now we discuss what is X-ray spectroscopy. The X-ray spectroscopy is a technique that detect and measure photons or particles of light that have wavelength range between X-ray radiation in electromagnetic spectrum. It is used to help scientific understanding to chemical and elemental properties of object. Here in this diagram we consider a sample. When electron beam incident on the sample, then two types process will happen to produce X-ray. The first one is Bremsstrahlung X-ray production, and another one is characteristic X-ray production. X-ray can produce when X-ray are emitted by sample, then detector will detect this X-ray radiation and get amplified and signal show in the computer. Now, the working principle of X-ray spectroscopy. This spectroscopy work on method involving interaction between electron beam and the X-ray with the sample. It is made possible by behavior of atom when they interact with radiation. This interaction like photon interact with material. When this material excited with high energy, or otherwise we say shorter wavelength radiation, then this material become ionized, and this ionized when an electron from inner shell of an atom is excited by the energy of photon, it's moved to higher energy level. When atom is moved in higher energy level, it become unstable. So it to get stable state is returned to low energy level. At this moment, the energy which is previously gained by this electron is emitted as energy of photon, which is the wavelength that is characteristics for elements. Thus, we can say atomic X-ray emitted during electron transition to inner shell state in atom of modest atomic number. These X-rays since have characteristic energy related to the atomic number, and each element therefore has characteristic X-ray spectrum which can be useful to identify the element. Now let's talk about working process of X-ray spectroscopy. An X-ray spectroscopy work because when X-ray beam incident on sample, some of the energy is scattered, but some are also observed within in the sample, and the manners that depend on its chemistry. The incident X-ray beam is typically produced from an RS target, although tungsten and chromium and other also be used. depending on their applications. When X-ray hit the sample emit X-ray along a spectrum of wavelength characteristic of the type of atom presents. Now, if a sample has many elements present, the use of wavelength dispersive spectrometer allow to separation of a complex emitted X-ray spectrum into characteristics wavelength for each element present. Various type of detector used to measure intensity of emitted radiation. The intensity of the energy measured by these detector is proportional to the abundance of the element in the sample. The exact value for each element is derived from standard from Fourier analysis for other techniques. Now we talk about instrumentation of X-ray spectroscopy. The component for X-ray spectroscopy are: first one is X-ray generating equipment like X-ray tube, second is collimeter, third one is monochrometers, and last one is detectors. Now one by one we can see working process of these components. Now the first one is X-ray generating equipment, which is mean X-ray tube. The X-ray can be generated by an X-ray tube. This is X-ray tube. This is a vacuum tube. Here this is a copper anode. This is filament. And this filament emit electron. The electron travel and hit the copper anode and generate X-ray beam. This X-ray tube is vacuum tube that use a high voltage to accelerate the electron released by hot cathode to very high velocity. The high velocity of electron collide with a metal target and then anode creating X-ray. So by using the X-ray tube we can generate X-ray. Now the second component is collimeter. A collimeter is a device that narrows a beam of particle of waves, which means this collimeter is used to narrow beam to cause of direction of motion to become more aligned in a specific direction. Collimeter is achieved by using a series of closely spaced parallel metal plates by bundle of tube which is length 0.5 less diameter. So we can say that the collimeter are used to the focusing X-ray beam in a particular direction. The third part of X-ray spectroscopy is monochrometer. The monochrometer crystal partially polarized and unpolarized X-ray beam. The main goal of the collimeter is to separate and transmit a narrow portion of optical signal chosen from a wider range of wavelength available at the input. So we can use two type of monochrometer. First one is metallic filter type and second one is diffraction grating type. Now the last component is X-ray detectors. The most commonly used to detect the X-ray radiation is solid state detectors and scintillation detectors. The first detector is solid state detector. This solid state detector have charge carrier or electron and holes. When radiation incident on the in depletion region, then semiconducting junction produce electron hole pair. These electron and hole pair are swept away in the influence of the electric field, and proper electronics and collect the charge in the pulse. The second detector is scintillation detector. The scintillation detector consists of scintillator and a device such as PMT photomultiply tube that convert the light into electric signal. It consists of an it consists of an glass tube containing a photo photocathode. Typically 10 and 12A cathode are uh, are called diode and anode. Electron emitted by the photocathode are attracted to the first anode and are accelerated to kinetic energy equal to the potential difference between the photocathode and the first diode. When these electrodes strike the first diode, about about 5 electrons are ejected from the diode for each electron hitting it. These electrons are attracted to the second diode and so on, finally reaching the anode. The total amplification of the PMT is the product of the individual amplification at each diode. The amplification can be adjusted by changing the voltage applied to the PM relay. Now let us talk about application of X-ray spectroscopy. X-ray spectroscopy is used in wide range of applications including research, sedimentary and metamorphism, petrology, soil survey, cement production, as well as meteorology and environmental study. Now finally we talk about advantage of X-ray spectroscopy. X-ray spectroscopy is an excellent method to determine the structure of component. In any event that other spectral methods fail to reveal a component identity, but the X-ray spectroscopy is the method of choice for structural determination, as well as is used to other parameters such as bond length and the bond angle also are determined using the X-ray spectroscopy. Thank you.